All right, ladies and gentlemen, we're here. We're about halfway through. Let's see, what week is this? It's the 19th, 20th. Yeah, we're just about halfway through with our semester here. What I said, like I said yesterday, what I want to do today is is talk about the midterm. So in this first hour, what we're going to do is talk about the midterm. Let me go ahead and pull the slides up for you guys. Where are you? There you are. All right. So we'll go ahead and talk about the midterm in the first hour. I will go ahead and introduce conceptual database design in the second hour because, again, what I've realized is that 2 weeks is just not enough. 2 weeks is not enough for all of the database design stuff that I want to do with you guys. All right. So what I will also do is, because, let's see, today's the 20th. Yep. Because the group project is due during that midterm week, what I'll do is we'll go light next week, because some of you have midterms for other classes next week, and some of you, and then all of you have a midterm the following week with me, at the very least, and other classes as well. We'll go light next week so that you guys can focus on getting the group project finished up there. Okay, the first submission. Okay, all right. So I won't make you read all through this during this class, but these slides are available on the class materials. It's kind of a silly comic for that I put up for exam days and times. So just be cautious that, when you ask if something's going to be on the test, it's not about whether or not something's on the test. I don't teach you guys this because it's going to be on the test. I teach you guys this stuff because it's important concepts for you to learn, so that when you graduate from this university, you will be well prepared for your future career and life in general. Okay. All right. So how are we doing this thing? Midterm. All right. So the midterm is going to be on Tuesday, the 4th of May. Okay, the time is wrong. It should not be 9 to 12:30. It will not be a 3.5 hour exam. Typo on my part. Okay, actually, the fun thing is I can change that in real time, actually. So let me say, what was it? Okay. I will actually make this there. All right. Because I think some of you may have other things going on at 10:30, like other classes or other exams or other things. So we'll make it till 10:30. So it'll be an hour and a half exam. It'll be on here on the Teams channel. Okay. All right. So I'm glad we fixed that. All right. So I will make the exam 100 points. That represents 20% of your final overall grade. If you want to look at it as, what is that? Each 5 points on the exam is 1 point of your final grade. If you want to look at it like that, and it helps make you feel better about that grade. If that makes you feel worse and more nervous, don't think about it that way. Okay. I don't want you to be nervous. I don't want you to be concern. I want you to know that if you've studied and you've kept up with the course and you apply our skills, our engineering skills, that you can be able to do this. Like, it won't be a very difficult exam. Okay. Now, the topics that we will cover up through, let's see, we are on actually week 8 now. Yeah, so that should be up to week 8. All right, which is today. Okay, so notice that what's not down here is conceptual database design that we will cover today, and other database design topics that we will cover next week. I am not going to include that on the exam. So stuff that we cover in the second hour today, you will not be responsible for during the exam. Okay. You're only the only topics that will be on this exam, on the midterm exam, will be up through normalization, and there will likely be some small component related to the higher forms of normalization, you know, just to show that you understand that there are higher forms. But I really want you to focus on understanding how to normalize a database through the third normal form. Okay, that's what we're mainly wanting to have you understand. Okay. This is my general format, so just give you some short answer questions, you know, to stuff like multiple choice, fill in the blank, stuff like that. You will be expected to be able to write SQL statements. Normally, I would have had you draw an ER diagram because of, unfortunately, because of the nature of how things have to be done with this online format. I can't really give you a tool to draw an ER diagram. And so therefore, at least I haven't figured out a way. And so if I come up with a way to do it that is convenient and like appropriate, then I may include that. But I understand that some of you don't really have the technology. Like some of you may be taking this exam on a phone because you don't have access to a computer that has consistent internet access or something like that. So so I'm trying to figure out, you know, if there's a way to do this. But at the very least, I will give you an ER diagram, and you'll have to answer questions about how to understand the ER diagram. All right. Yeah, you'll also need to understand traps. Like, remember we talked about the fan traps and the chasm traps in an ER diagram. You'll also need to know how to take a data set and normalize it. So you'll want to be able to take, I'll give you some set of columns. It won't be 30 columns like your group project. It'll be something more like a simple example like what we did yesterday, where I give you a set of, you know, 8 columns, 9, 10 columns, something like that, with data inside of it, and you'll be expected to show how would you take that and bring that to the third normal form. Okay. All right. And then, of course, though, I will want you to be able to explain important concepts. This will be like the longer answer. If you want to think of it like an essay, it's kind of, but it's not long like an essay. It's not, you know, it's not multiple paragraphs. But I do want to have you be able to explain important concepts. All right. Okay. So this was a holdover from the final note from previous semesters. Obviously, I cannot include that or that or that in this, because how are you supposed to take the exam if you don't have a computer or a phone available to you, right? So you have to at least be able to have that. But the idea is still the same. The idea is still that you need to be able to work at this from your own understanding. The truth is, I try to design these exams such that if you do try to Google search answers, you'll get them completely wrong. If you do try to, if you try to copy from another source, it'll be wrong. You'll spend more time searching for the answer than you will if you just came up with it on your own, if you just designed it on your own. Okay. All right. I do want to have this as a holdover, one A4 sheet of paper that must be handwritten. Okay. And anything printed, like from a computer, like you did Microsoft Word or something like that, and printed it, or anything photocopied from some other student, it says will be taken. It will not be accepted. It will be, you'll get deduction and points for that. So the way that we're going to confirm that is I will have a section on the exam. So one thing Microsoft Forms allows for is for us to do file uploads, where I can have you upload a file. And what I will do is I will have you upload a couple of files. One will be a copy of the sheet. So you can take a picture of it with your phone. You can scan it with a scanner. You know, whatever. But remember, it has to be handwritten, so it needs to be a picture. Like, don't upload a PDF of your Microsoft Word document. That would just be totally wrong. But so it needs to be a scanned or or photograph of the thing. And then I want you to and then I'll have another one where I want you to upload a picture of you holding your form, of you holding your sheet. Okay, so comb your hair, brush your teeth, look nice, because you'll have a picture of you holding your sheet, and you'll have to upload that as well. Okay. All right, and this won't be shared. I'm not going to like post this on social media. I'm not going to post your pictures to my Facebook account or anything like that. Okay. But I do want to see you and your smiling face with your sheet in hand. Okay. All right. So that's what you can expect from the exam. All right. I guess because there are people that are not able to attend this lecture live, I'll probably need to make some of those announcements, text announcements on the channel here, on the team channel. So, all right. So we can have a review session if you guys would like. Are there questions? Are there still things that you're just like, I just don't know if I quite understand a certain topic, Hojam? What is it that something that we can talk about related to the exam, not related to like other things in general. We can talk about other things in general offline, but particularly related to the database midterm exam, the topics we've covered so far, that you're still not quite sure you completely understand. Nothing? Well, either it's too early and you're not even awake enough to know what you don't understand, or
Sir, so I have a question.
Sure.
All right. I'm kind of struggling about the ER entities, I can say. My struggle is most about the like we have this group assignment about the hospital, so I don't want to talk too much. I don't think it's appropriate. I don't know. But when I'm trying to create an employee, something like an employee table, I am always not sure if it's like from 0 to infinite or from 1 to infinite. I'm always kind of struggling of deciding if this table can be like not non-existent in the list, or if it should start from 1. I'm like so that's like my question.
Right. So you're saying it sounds to me like what you're saying is you don't know whether to do this one or this one, right? The 0 or many or 1 or many on each side, right?
Yes.
Yeah, and basically that's a design decision. So let's talk about what the difference between those two would be. Those two options would be. Let's see if we can pull up an example here. Okay, like even on this side, right? So what the 0 to many over here. So first of all, the way we would call this relationship is a many to many relationship because it's many on this side and many on this side. So that's the first part of what I want to make sure that you guys understand. So if during the exam, if I say something about if I were to show you this, and I would say, what do you know from this diagram? I would want you to at the very least be able to, well, one thing you'd have to be able to tell me is that this relationship, this advertises relationship, is a many to many relationship. Okay, so that's one. Another thing that let's talk about why this side is 0 and this side is 1, because I think that's what your question is kind of asking here, is what's the difference between those two. And and what we're saying is that if we have a newspaper in our database, it must be advertising at least one property for rent. Like, in other words, if we have newspaper information in our database, right, we don't have any newspaper information in our database that doesn't advertise any properties. Right? And part of the reason for why they might design it this way is that they're saying we don't want to keep information about newspapers that we haven't used. Right? There's thousands upon thousands of news sources out there in the world, and we only want to keep information about newspapers if they're actually being used by our system to advertise our properties. All right, so that's why this 1 is here. What it's saying is that newspaper is required. Okay. Property is required. So property must participate in the relationship. Right. Now, the other side of this, the 0 on the newspaper side, means we can have a property that we don't require that it be advertised in a newspaper. Okay. So property can be advertised in many newspapers, or it could be not advertised in any newspapers. So I'm not sure about your particular example. You talked about employee. I'm assuming that employee would be an entity on one side of a relationship, and there might be something on the other side. Well, let's not use the hospital example. Let me think. You might have like at a bank, right? I think the example I went over with you guys on a few weeks ago, where we kind of did a what's it called, an ER on that diagrams.net. Let me see if I can find it. See if I can open up. Examples. Oh, it was an app store. We went over the app store example. That's what we did. Right. Okay, so actually you can't see that yet, can you? Let me change how my screen sharing is done so that you can see this. So we'll do it this way. Right, where we had here. So here we have a couple of different types of relationships where we have a user, we have an app information, we have a developer, right? And the way that we designed this was we said, so let's look at this because the two different types. Here's a required many-side relationship, and here's an optional many-side relationship. So here what we're saying is that if we have a developer in our system, we are going to require that they have an app in our system. Like, we're not going to keep information about developers that haven't uploaded any apps to our system. All right. Okay. So that's a design decision. Now, if we change this, where are you? If we were to change this and say, let's make this a 0 to many, which would also require that we change this to a, where are you? There you are, right there, like that. Okay. Then what we're saying is we're allowing developers to be stored, developer information to be stored in our database that don't have apps, that haven't uploaded, that have not developed and uploaded any apps to our system yet. Okay. And basically that's a design decision that you that you have to make, that you may have to make with consultation with your customer. So like in a real world system, that would be the kind of decision that you might make either on your own, if the customer has said, I don't care, just do whatever you want, or if the customer has a particular opinion or particular desire in that matter. I think the reason why we did this way last week, or a few weeks ago when we did this, was to show a difference of a required mini and an optional mini is what we is the reason we did it this way. Okay, so basically a required simply says this side must participate in this relationship. If we have a developer, they must have an app in our system. What that means is, and what we'll talk about once we get into logical design, is we'll talk about what that difference, because that's not, that seems like that might be a very simple change. And for the diagram purposes, it is. It's just a simple, oh, change this from a 1 to a 0, right? Change this from a 1 to a 0. That's easy for us on the diagram. There are differences in how that's going to look in the database itself, because we'll have to put constraints into our database to make that happen. Okay. So let's talk about then, what about this optional mini? Again, the whole idea, the optional mini just means that we, whether or not this entity participates in this relationship. The reason why we say this is optional, so I meant to put this here to show that this was 0. Yes, there. All right. Right. So when we say that this is optional, what we're saying is if a user exists, they don't have to download any apps, but they can download as many as they want from our store. If an app exists, it doesn't have to be downloaded by any users, right? It doesn't have to be downloaded by any users, and it can be downloaded by as many users as we want. All right. We could put a restriction like this. We could say something like this, where what we're saying now is we're saying a user doesn't have to download any apps, and they can download up to 20. Once they download up to 20, they either have to they can't download any more, or they have to delete one before they can download another or something like that. That seems like a really silly restriction, right? We wouldn't do that to our users. Right. But consider this. What if we did this? What if we did? Okay. How does that change the meaning on this? Let's see. I want to change this to a required mini. Nope, other side. Needs to be this one. Okay. How does that change? What did this change based on our discussion so far, what we talked about? how does this change, and what does it mean for the way that our system is now going to function? That simple change right there.
Is it like there has to be at least one application, but it doesn't need, it's not required to be downloaded by a user?
Okay. Right. Well, this question, by the way, was for anybody, not just you, Atakan. This question can be answered by anyone, because this is the type of thing that I might put on this exam. Is I might make a diagram like this, and then make a couple of changes. Like I might say, this is one diagram, this is another one, right? That simple change, just that one little change, right? And I might say, how does that change the system? What is different about what we've designed, the two different systems, system A, system B, what is the difference between them in terms of how they function? All right. And I would expect you to be able to understand what a design decision like this, how that would change the way it functions, how it operates. All right. And so what you said is, you said an application has to exist, but it doesn't have to be downloaded by any users. And that's right. Like, so if an application exists, there is no requirement that it be downloaded by any users. That's right. But what about the user? If the user exists, what has to be true about the user?
Hocam, is it about
Oh, you're kind of breaking up. It's like really like bad.
voice is clear? Not clear. Oh, okay.
Yeah, your audio is really, I don't know if it's something up with your microphone or I don't think it's my speakers, but it could be.
So if there exists a user, the user must download at least an application, right?
Right, they must download at least one application. Yeah. So if a user exists, they have to have if a user exists, they have to have at least one, and that's if we named, I mean, assuming that's if we named this downloads. Right? A user downloads applications, right? Right. So we would say, developer develops applications, a user downloads applications. Another possibility is what if we change, let's see. Another thing we could do is we could also have a second relationship up here between users and app info. That's going to be all right, and we call it views, right? So you don't necessarily have to view an application. You don't necessarily have to download an application, but you could view it, right? We might have a double relationship between the two, and we might say something like this, right? And all these, so that could be another difference between two different diagrams, and you would have to say, okay, well, what we're saying is that a user must view at least one app in order to be saved in our system, but they don't have to download any, right? and how we put these restrictions on these things like this required. Putting a requirement on one side and not on the other, or putting on a requirement versus not required, that kind of thing. It changes the nature of the relationship. It does, and like I said, what we'll learn in a few weeks when we talk about database design is how that changes constraints that we put into our database tables. We'll talk about that later. But what I'm mostly interested in you understanding right now is how does putting a requirement versus not, putting a requirement on one side versus not, what does that reflect in a real world understanding of how the database operates, right? Because by putting a requirement on here, we're saying a user cannot exist unless they've viewed an application. So in other words, it's almost like when they log in the first time and create a user account, they automatically have to view an app, right? And how would we do that? And I'm not saying that there's anything wrong with that. There's nothing wrong with that design, but there would be questions about what does that mean, right? What does that mean for the way the design decisions work? Okay. One thing that I was actually talking with a friend of mine yesterday about, that I used to, some of my students in years past, I haven't used this term as much recently, but the term trade-off. And every time that we make a design decision, oftentimes we're reflecting a trade-off. Right? We are gaining one thing and losing another. Right? The example that I gave with my friend was the ATM at a bank. Right? And so here in Turkey, my experience has been that when I go to the ATM, when I go to my bank, I put my card in, I put my PIN, and I say I want, however much money, 200 lira, 300, whatever. And I need to get cash out of the ATM. And when it gives me the money, it also gives me my card. And my transaction's over and I walk away. Right? American ATMs don't work that way. American ATMs require the user to say, I'm done, exit, give me my card back. All right. For any transaction, like, yes, some of my transactions I do at the ATM here in Turkey do allow for, continued transactions. But if I'm getting money out, it gives me money, it gives me the card, and it says I'm done. And if I want to do more, like maybe pay a bill or deposit money into another account, like I've got to go back in. I've got to put the card back in and start the whole process over again. Right? So the trade-off here is if all I'm there at the ATM to do is get money and go, right? That step, that sending me the card without me asking for it, sending me the card saves me time, saves the user time, right? So I can get my money, get my card, and walk away. I don't have to do an extra step of telling it, give me my card. Right? The American ATM, what that system is saying is they don't want to do anything without explicitly asking the user first. They want to make sure that the user always says exactly what they want to do. Right? So trade-off here in Turkey, positive side of things is if all I'm doing is getting money, it saves me time and I can move on. The negative side of things, if I have additional transactions to do, I have to go back into the system and it uses more time. All right? And so the opposite side is true as well. And on the American ATM side of things, if all I'm doing is getting money, I have to use extra time to say after the money comes out, then it says, do you have any other transactions? I have to press no, and then they give me the card. So it uses more time. But if I have additional transactions after I get the money out of the bank, then I don't have to re-enter the system. And so it saves me time in that situation. Right? So in the same way, how we make a difference between these two options, right, reflects how the system's going to operate, and there could be a trade-off here. right? If we require users to at least view an app or to download an app or whatever, if we put a required participation on that side, what does that reflect in how the system is going to operate? It means that when a user creates their account, they can't just have an account with no apps, right? And this might be how this works. This might be how this works in a like I have an iPhone. This might work how it works in the Apple's App Store, right? Is there maybe certain apps like Settings, Safari, what's another Apple app? The App Store app, right? That might be like, okay, you're required to at least have that. So that might be that we could say, well, they're at least required to have the App Store app, so we need to at least include a 1 there, right? Right. They're at least required to have the phone app. They're at least required to have the messaging app, right? So they might have like a requirement like that, where that requirement reflects that that kind of design decision, that there are certain apps that we will require them to have on their phone in order to function. Right? If we say 0, we say they're not required to have any of these apps. All right. Then what does that mean? It means that they can have a phone that has nothing on it, and that's okay. All right. All right. You know, we could also have just to really kind of have some fun with this, we could have, I don't know what attributes there would be, but we could say, where's my, I want my, yeah. Let's see. And where? Actually, I think, is this it? Nope, wrong one. Where you might have certain, where's my UML? There we are. Okay, where are you? All right, where we might say that a user can download 0 to many apps, of any kind of apps, of normal apps, but they might be required to have certain core apps like Settings and Phone and App Store app and messaging app. Right? So there might be some apps that are required, and then other apps that, you know, they can have them, they cannot have them. Right? So this might reflect an even more nuanced or refined version of this, right? Okay. Yeah, and you will be expected to know what this means. This comes back from UML from your 101, 102 days, so there's no reason you shouldn't know what the extends, what the generalization relationship does. All right. Okay. So if there aren't any other questions on review, and again, I'll be available. You guys want to just, you know, message me offline, that's fine. And you can ask some other questions as well. All right. So what we'll do is, it's a little bit early, but we'll take a break now if there aren't any other questions. and we will come back at 9:20. I will introduce conceptual database design just for a little bit today, and we'll call it a day there. All right. See you in about 10 minutes.